Hello people, welcome to my first video. Today I will be explaining how to solve circuits with operational amplifiers. Okay, but what does it mean to solve a circuit? Well, it means finding a mathematical equation that connects the input and the output. In this case, we use the following notation. The voltage output is equal to a function of the voltage input. And I have chosen this circuit as an example. An operational amplifier creates an effect in the circuit. Think of it as a black box. We know the input and the output, but we don't always know the exact process happening inside. Operational amplifiers are used in computing to build analog adders, multipliers, differentiators, and integrators. In sensors, they are used for filters and signal processing. In electricity, they help measure electrical power, but these are just a few examples. Actually, they are used almost in every electronic circuit. Also, an operational amplifier is an active component, which means it needs external power to work. To solve the circuit, we will follow three simple steps. We will first calculate non-inverting input and inverting input, and later we will set B plus equal to B minus. Why is that? Well, a virtual short means that in an ideal operational amplifier, the voltage at the non-inverting input B plus and the inverting input B minus is almost the same. This happens because the amplifier has a very high gain, so even a small difference is amplified a lot. In practice, we assume B plus and B minus are equal. Also, we need to know that the input impedance is very high, so the current entering the non-inverting terminal is almost zero, and the same will happen to inverting terminal. We will use Ohm's law to calculate the current, in which the voltage is equal to the resistance multiplied by intensity of the current. We will set an arbitrary direction of the electricity to perform the calculations. Okay, so the E1 is equal to B plus, minus B in divided per 1K, which is 0. Why? This is 0 because the input impedance is very high. So we know the current will be 0. No current is entering or going outside from a really high resistant input. Okay? So performing really simple mathematical operations, we will find out that B plus is equal to B in. Also, we will calculate now inverting input. Okay, it happens the same thing. This current A2 is 0. Why? Because the input impedance is very high, so no current is going out. So because of that, we know that E3 will be equal to E4, right? If this is 0, this will be equal to this, and we will calculate B out minus B in divided per the resistance 5K is equal to B minus 0, which is the ground, divided per 1K. Performing again really simple operation, we will find out that B out is 6 times B minus. Now we will do the third step, which is setting B plus equal to B minus. If you remember previously, I said that B plus is equal to B in, and now we found that B out is 6B minus. So we can say that B out is equal to 6 times B in. And now we have solved this circuit. As I said at the beginning, our goal was to find the formula that connects B out with B in, and we find it here. B out is equal to 6 times B in. Okay, if you like this content, if you want me to create more videos about circuits and electronics, drop a comment, drop a like, and subscribe. Thank you so much.